Okay, let's take a look at an exponential function. An exponential is not linear, so it's not a line, but it's not like the quadratic that increases and decreases. It either increases as the one that we see here, or it could decrease in this example. So an exponential function. Let's first identify where it crosses the x-axis. So again, that is where y is 0, and it crosses right here on the x-axis, and that's -3, 0. The y-intercept is where our graph crosses on the y-axis, and that is when our x-coordinate is 0, so 0, 10. We write our x and y intercepts as ordered pairs, x, y. With exponential graphs, we have an asymptote, which is a line, and this is going to be a horizontal line that our graph approaches but never crosses or touches. So down here, we are going to highlight our asymptote of this horizontal line. And this time, when we write our equation of a horizontal line, it's going to be y equals the value that it passes through on the y-axis. So y equals -2 is the equation of our asymptote. Our domain for this exponential function, we have arrows on both ends, so our graph can go forever to the left and forever to the right. So we have no restrictions of our domain. Now for our range, which are the y values, we are going to always ask how far down does this graph go? So this graph, this function goes all the way down to -2. So the graph gets closer and closer and closer to y equals -2, but it never touches or crosses the asymptote. So we're not going to include -2 as part of our range. So it goes down to -2, and then it goes up to positive infinity. So we're going to use a parentheses for the -2 because it does not include -2, and then it continues up toward positive infinity. Our interval of increase and decrease is similar to that of linear functions. It's either one or the other. As we read from left to right, our graph is increasing. It's going up, 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 and it is increasing from negative infinity to positive infinity. There is no interval of decrease. There's no x value that's ever going to cause this graph to decrease, to go down. So we're going to use the null symbol. Now let's take a look at the interval of positive and negative. So interval of positive is asking what x values, so we're looking at the x-axis, what x values cause this graph to have positive y values. What x values cause the graph to be above the x-axis? So beginning from left to right at -3 to positive infinity, the graph is above the x-axis, giving us positive y values. So from -3 to positive infinity, the graph is above the x-axis. And then the x values that cause the graph to be below the x-axis is from negative infinity up until -3. All of these values have a negative y value. So from negative infinity to -3, the graph is below the x-axis and our y values are negative. Now let's take a look at end behavior. For end behavior, we are going to use our asymptote. Asymptote is also used for our range. So we are going to ask, as the x values approach negative infinity, as we go left on the coordinate plane, what is happening to the y values? They are getting closer and closer and closer to that asymptote of -2. They cannot go past this boundary line, this asymptote, so it approaches -2. So the left side of our graph approaches -2. The right side is going to approach positive infinity. So to write notation for the right side of your graph, we're going to say as the x values approach positive infinity, the output values approach positive infinity. As we go right toward positive infinity, the output is going toward positive infinity.